At Balchem Animal Nutrition and Health, we strive every day to deliver results you can see in your animal's productivity and your bottom line. From a smooth transition into the milking string for your fresh cows, to a happy welcome home from your furry friend. From a strong start in your poultry flock, to consistent weight gains for your finishing hogs. We expect to earn your business and your trust with our people, our products, and our science. Our people have an intense passion for your animals and your success. You can count on us for honest, candid advice and practical solutions for your toughest challenges. As the global leader in choline production, chelation, and encapsulation technology, we take our obligation to you and to the environment seriously. Our products are backed by the most extensive and thorough research portfolio, while our business is committed to advancing environmental sustainability and animal welfare. In the end, it all comes down to results. Balchem delivers real results you can count on, results that exceed your expectations, and results that bring true value to your bottom line. Leading the charge to meet the nutritional needs of ruminants, monogastrics, and companion animals, Balchem offers a growing portfolio of nutritional products and a dedication to innovation and industry sustainability. Balchem is here to solve today and shape tomorrow.
The Kentucky Equine Research Performance Center is a new facility for KER located in Ocala, Florida. Most of the research that we've done in the past with exercise has been on high-speed treadmills, which really gives you fairly intense exercise, but you can't mimic racing. There's only one way that you can mimic racing, and that's with a racetrack, so it puts us in a whole different realm in terms of being able to measure horses under racing conditions. We've been interested in all types of performance horses for all 30 years. Recently, though, we've become more focused on thoroughbred racehorses. We think that's a real growth industry. There's some interesting things we can do nutritionally. And as we got into that, we discovered that to study racehorses, you need racehorses. That's truly what KER is about, and that is testing our products, doing research, and then applying that research in the real world.
Hello, everyone, and welcome to the Real Science Lecture Series. My name is Scott Sorrell, Director of Global Marketing for Balchem. Today, we're excited to delve into a new segment for the webinar series. We're going to be talking about equine nutrition. And we've brought in one of the best in this arena, Dr. Joe Pagan with Kentucky Equine Research. He will share the newest research in performance horse nutrition. Dr. Pagan received his BSA degree from the University of Arkansas in animal nutrition and received his MS and PhD degrees from Cornell University in equine nutrition and exercise physiology. He formed Kentucky Equine Research in 1988 to be the international research, consulting, and product development firm dealing in the areas of equine nutrition and sports medicine. Kentucky Equine Research serves as the equine nutrition consultants for the last 6 Olympic Games, and Dr. Pagan received the 2005 American Feed Industry Association Award in Equine Nutrition Research. This award recognizes excellence in equine nutrition research and the contributions of an individual to equine feeding management practices and the equine feed industry. Dr. Pagan, thank you for joining us today, and you should now have control of the screen.
Okay, thanks, Scott. So you can see my screen and hear me okay?
Yes, we can.
Excellent. Well, it's a real pleasure to be here to talk to you about some recent developments in performance horse nutrition and tell you from my viewpoint what we really should be concentrating on in the performance horse sector. I'm going to speak about performance horses, and I think we need to kind of get all on the same page of what is a performance horse, because in reality, there's a lot of different types of performance horses. They do a lot of different things. The thing that puts them all together is they exercise. So this is the central theme here is the exercised horse and how do we optimally feed and manage it. Energy is the nutritional factor that's most influenced by training and work. And so this is the area that I'm going to spend the bulk of my time today talking about. Energy is a very important factor, and what we feed a specific type of performance horse is very, very important. Fortunately, the horse has a really good, well-developed and complex system to take chemical energy and turn it into mechanical energy. There's a lot of biochemical pathways where horses can burn fuels and produce adenosine triphosphate, which is really the fuel that they use for fueling muscle contraction. We have a choice of basically 4 different things that we can feed a horse to supply its energy needs. We can feed the horse plant fiber, non-structural carbohydrates, starch and sugar. We can feed it fat, or we can feed it protein. So today what I'd like to do is go through each of these different types of energy sources and give you an idea of when they're appropriate, how much is appropriate, and some of the things that we need to take care of when we're feeding these different types of energy sources. Now, obviously, plant fiber is a very important energy source for the horse. After all, that's what the horse evolved to eat. Horses evolved as wandering herbivores. They've got a huge hindgut that allows them to process a lot of forage at a time. If we take a look at a horse's digestive tract, here I have it on the right, you see that they're monogastrics. There's a small, simple stomach, and look at it in relative to the size of the total GI tract, a narrow small intestine, and then a really big cecum and colon. Horses evolved this digestive tract with the strategy that they're going to eat lots and lots of forage. Not really all that concerned about how high quality it is. The name of the game is eat a lot, move it into the hindgut where it can sit for a while. So this digestive tract is really well made to eat nothing but forage. But when man domesticated the horse, he realized that he couldn't meet the horse's digestible energy requirement just from forage, so they started feeding other forms of energy. And the one they went to initially was cereal grains. Cereal grains were plentiful, horses liked them, and they did well during work. So we took a horse whose digestive tract was designed to be fed high levels of relatively moderate quality forage, and we started feeding them cereal grains. So we switched one of the predominant digestible energy sources from plant fiber to non-structural carbohydrates. Non-structural carbohydrates are actually quite versatile for the horse to use. This is a slide that kind of gives you an overview of the entire horse's body. We have the GI tract represented over here, the liver that can be used for processing and storing substrates, and then there's adipose tissue, the bloodstream, and finally the muscle cell. The muscle needs to be able to take these fuels, convert them to ATP so it can make the muscle contract. Glucose can come from starch in the diet. If we feed cereal grains, it can be stored as liver glycogen, and it can also be stored as muscle glycogen. Both liver glycogen and muscle glycogen are recouped from blood glucose. So glucose is a major substrate for energy generation. It's used effectively, and I'll show you in a little bit that the harder the horse works, the more it needs glucose. So glucose during rapid exercise can provide ATP 2 different ways. It can do it aerobically by burning glucose to produce carbon dioxide, and water produces a lot of ATPs. In a pinch, when the horse is really needing to exercise hard, it can actually use glucose anaerobically to produce ATP. Does it really fast, but it produces lactic acid, which is self-limiting in terms of how much energy the horse can derive from this anaerobic glucose utilization. So when we supply non-structural carbohydrates to the horse, if we're looking at it in a horse feed, we're typically looking at cereal grains, and we can break those down into 2 different parts: starch, which is a string of glucoses, And water-soluble carbohydrates are sugars, which are either in monosaccharide or disaccharide forms. The problem we have is the horse's digestive tract wasn't really designed to eat a lot of starch. Again, let's take a look at the way the horse really should be digesting things. We've got a small stomach and small intestine. The dietary strategy is push stuff through there very fast. Rate of passage through the stomach and small intestine is about 2 to 6 hours. So food goes very fast through there. To compound problems, horses don't really produce a lot of amylase. They didn't really evolve to eat a lot of grains, so they're not great at producing the enzyme to break down starch. They're kind of down on the same area as a carnivore when we talk about amylase, where on the other extreme, if you have a pig that produces heaps of amylase, they can digest the starch very easily in the small intestine. So horses have a problem in terms of digesting starch in the small intestine. The type of grain actually makes a pretty big difference. Oat starch is more digestible than barley starch, is more digestible than corn starch. You can also process grains and improve the digestibility. But studies have been done that show if you're feeding straight corn, that up to 70% of the corn starch can escape digestion pre-cecally and end up in the hind gut. When that happens, the starch is actually fermented in the cecum and colon. Bugs in the hind gut do a good job of fermenting starch. They do it very rapidly. They produce volatile fatty acids and lactic acid. When they produce a lot of that, it can create a significant drop in pH. And you come up with a syndrome called hind gut acidosis. And this is something that we've been concentrating on a long time. This is one of the main drawbacks of feeding horses high carbohydrate diets. What happens when you have hind gut acidosis? Well, number one, it irritates and damages the intestinal mucosa. It can also increase the permeability of large toxins and other large molecules that normally wouldn't have leaked across the intestinal mucosa. And some of these are implicated in the development of equine laminitis. So there's a downside to what happens with hind gut acidosis. What do you see in the horse? Anorexia is one thing. The horses don't want to eat. They may have high energy requirements, but they still don't have any appetite. They can colic, have ongoing chronic colic, and they develop stereotypic behaviors like wood chewing and stall weaving. So these are all things that you might see in a horse that has hind gut acidosis. Now, acidosis is not something that's unique to the horse. In fact, if you guys that are in the dairy industry and beef industry, you see it all the time. Rumen acidosis happens pretty commonly. You feed a ruminant a large amount of grain. The grain goes directly into the fermentation vat, the rumen in this case, and you get rumen acidosis. Well, in a cow, you can feed that cow sodium bicarbonate. It's an effective buffer. It's a quick buffer. It can be added directly to the cow's ration, and it'll buffer this pH. It'll attenuate a drop in rumen pH, and the dairy cow will do better. It will increase its feed intake, and it'll improve its milk production. So this is something that's been used in dairy forever, and that's feeding sodium bicarbonate to reduce rumen acidosis. Our problem with a horse is we want to get the sodium bicarbonate into the large intestine, and the anatomy of the horse makes that difficult. Because if we feed sodium bicarbonate, it has to survive the acidic environment in the stomach. It has to survive the digestive enzymes in the small intestine. It has to arrive in the large intestine, and then it needs to be available to disassociate, to provide bicarbonate, to buffer back there. And that had always been a problem when we were talking about feeding horses, because how do we get these buffers into the hind gut? Well, several years ago, I got visited by someone from Balchem, And we get visited all the time. Our business is doing equine research and product development, and companies come to us quite often and they say, hey, we've got some products that work in other species. Will it work in horses? So the Balchem rep said, we've got encapsulation technology. We've got this wonderful technology. We can encapsulate all sorts of things. Is there a place for it in equine nutrition? And I said, yeah, bring me an encapsulated sodium bicarbonate. And now we're talking. And he said, oh, we already do that because it's used in the baking industry. So we got our heads together. We created a joint venture to create an equine hindgut buffer. We told Balchem what the dissociation characteristics were that we were trying to do. They went back to their lab. They created an encapsulated sodium bicarbonate that will make it through the stomach and small intestine, but will dissociate in the large intestine. And Equisure was born. We did a bunch of studies looking at the efficacy of Equisure in models where hindgut acidosis was created. We presented these data at the American Association of Equine Practitioners conference. That was the first study we presented. And basically what we did is we created hindgut acidosis in heavily exercised horses by feeding a high grain diet. We then fed the same horses the same diet plus Equisure. And what we were able to do was attenuate the drop that we see in pH in the hindgut after we feed a high meal, much of which is created from lactic acid production. So here, we didn't bring in a new ingredient. We knew about sodium bicarbonate for a long time. We brought in a special technology, a delivery technology that allowed that to go to the hindgut. And this has been an invaluable tool for us for years and years now in terms of dealing with hindgut acidosis, not only from high carbohydrate, but also from fructans, from horses that are out on high fructan grasses. So this has been a management tool with high carbohydrate diets. Now, obviously, at the same time, everyone was looking for, if fiber doesn't provide enough energy, if there's some issues with carbohydrates, what else can we feed? And what we can feed is fat. And so back in the 1980s, there was a big rush, a lot of people doing research on feeding fat to the performance horse. Fat can be fed in the diet. The fat is released as free fatty acids, can be used in the muscle cell to develop, to generate ATP. So fat can be an effective substrate for energy generation in performance horses. Some of the first work that I did was actually on feeding fat versus carbohydrate. I did a postdoc after my PhD in Sweden. And I did it in Sweden because they were one of the few places that had a high-speed treadmill we published the paper in 1986. We were interested in these alternative fuel sources for performance horses. Later at our lab here in Kentucky, we did some very sophisticated look at glucose kinetics and substrate oxidation in low intensity exercise. In this study, we used stable isotopes to look at how well horses are using different substrates during exercise. And what we were interested in was if we substituted calories away from NSC to fat, how did the horses handle that? And were they able to switch substrates during exercise? This graph here shows the digestible energy contribution for the two diets. And I'm going to use these designations a lot, and you've got to get used to this. This is different from us saying what percent NSC or percent fat was in the diet. This is how many of the calories, the digestible energy calories, are coming from these different energy substrates. This is the way we look at energy when we're formulating equine diets. We acclimated the horses to fat. We did standardized exercise tests. Here you see on the treadmill, the horse, this is a calorimeter. We're measuring the amount of oxygen consumed and carbon dioxide produced. That tells us whether the horse is burning fat or carbohydrate. We use stable isotopes to see what was happening with glucose oxidation. And what we found when we studied glucose kinetics was feeding fat really changed it. The amount of glucose that the horse depended on from the liver really dropped when we switched the horses onto high fat, and overall glucose utilization dropped as well. That was reflected in the respiratory exchange ratio, RER. Again, this shows how much carbohydrate was being oxidized compared to fat. A 1 means they're burning pure carbohydrate. A 0.7 means that they're burning pure fat. We showed we could switch the horses to where they burned more fat. So over a 5-week period, we saw that horses use significantly less carbohydrate and more fat during prolonged exercise. So that was a good thing if we're talking about endurance type exercise where the horse is going to be exercising over a long period of time, because running out of glucose is one of the things that will cause fatigue in long, slow exercise. But we have to remember, horses, when they go fast, they use glucose. And this is a slide that shows the relationship between muscle glycogen utilization and speed. And what you can see is it's an exponential relationship. So as horses are going slower, like you might have in an endurance type exercise bout, they're not burning a lot of muscle glycogen. When you get up to the point where they're going fast, and above a 2-minute mile would be standardbred and racing kind of speeds, they burn a heck of a lot of glycogen. So we wanted to know, well, if we're going to feed high fat and we feed it to a horse that burns a lot of glycogen, how well can they replete glycogen? So we did a study where we fed horses that were in intense training that we could deplete muscle glycogen, diets that were either high in non-structural carbohydrate, moderate, or low. We kept these diets isocaloric by substituting the amount of fiber and fat as we went from high carbohydrate to low carbohydrate. When the horses were on these diets, they were in an intensive training protocol on our high-speed treadmill, and we purposely depleted the amount of muscle glycogen they had. Over a 3-day period, we exercised them really hard, trying to reduce the amount of glycogen that they have in their muscle, because we wanted to know how well do horses replete that glycogen after they're done exercise. How can you refill the gas tank after exercise? What we found was very important. We found that when we started with a full tank of muscle glycogen and we purposely depleted it about 30%, over the next 3 days, it took a long time for that muscle glycogen to be repleted. Even in the high carbohydrate diet, it took a full 3 days for the horses to replete muscle glycogen. But look what happened when we depended on fat and fiber. We actually never repleted muscle glycogen. They weren't able to replete the glycogen that was utilized. We've done some really interesting collaborative research over the last few years with Michigan State University. Dr. Stephanie Valberg at Michigan State, her lab has some incredible techniques looking at proteomics and gene expression. We took that technology that Michigan State has, and we looked at these muscle glycogen, or these muscle samples that we took, to try to understand why horses weren't repleting their glycogen as quickly as we thought they would. In order for glycogen to be repleted, the rate limiting step is getting glucose into the muscle cell. And there are transporters that transport glucose from the cell membrane into the muscle where glycogen can be repleted. And these transporters are called GLUTs. And one of the main ones is GLUT4. It is already in the muscle, but insulin binding to the muscle stimulates GLUT4 to come up to the surface, grab the glucose, come in, and replete glycogen. There's GLUT1 as well that brings glycogen in as well. It's already been shown that horses don't do a great job of upregulating GLUT4. Humans, GLUT4, that transporter is the main one that's used. Horses in vitro with insulin stimulation, where humans might translocate 80% of their GLUT4, horses only translocate 15%. And if you look at how well horses can resynthesize glycogen post-exercise, they don't do it nearly as good as humans. And one of the problems is they don't use GLUT4 very effectively. Well, there are multiple glucose transporters in muscle. There's about a dozen of them. Again, in humans, GLUT1 and GLUT4 seem to be the main ones that are stimulated to replete glycogen. Aerobic exercise stimulates those. During resistance training, some of these other transporters are also stimulated. So Michigan State took these muscle samples and they quantified gene expression, and they were particularly interested in gene expression for these different types of glucose transporters. And what they found was really interesting, that when the horses were on the high carbohydrate diet, there was several of these glucose transporters where gene expression was increased compared to pre-exercise. But when they were on the low carbohydrate, high fat diet, there was low gene expression for 24 hours post-exercise. So this is a clue. These are early days. This is brand new data to show that there are some differences in gene expression that may explain how glycogen repletion is affected by substrate. So horses seem to lack the signaling mechanisms that activate the GLUT4 transcription. And there seems to be a lag in more of a lag in glycogen resynthesis when you feed low NSC, high fat diets. And it corresponds to a lag in some of these other glucose transporters. So bottom line here is, in situations where you need to replete muscle glycogen, you need carbohydrate in the diet. Now, when we add fat also, all of the time that we've added fat from back in the 80s, we were looking at fat as a substrate for generating ATP. So fat as firewood. We didn't really care what the fat was. It could come in any form. We've now, since that time, learned the type of fat is very important, not for energy generation, but for a lot of other metabolic activities within the horse. So when we measure fat in a horse feed, we do it as crude fat. They're mostly triglycerides, but those fatty acids in the triglyceride can be saturated, monosaturated, or polyunsaturated fats. The acronym's PUFAs for that, and those are omega-3 or omega-6. So if we look at a fat's a bunch of carbons with hydrogens. There's a hydroxyl group on one end. Saturated fat has no double bonds between the carbons. Unsaturated fatty acids have double bonds. In this case, I'm showing a single double bond that makes this an unsaturated fat. With no double bonds, in this case, this is an 18 carbon stearic acid. If there's one double bond, it's a mono unsaturated fat, and this is oleic acid. Two double bonds, and it becomes polyunsaturated. So we have these different types of fats. Within the polyunsaturated, you can further describe them as omega-3 or omega-6. This only pertains to polyunsaturated fats. What does that mean? It means where's the first double bond in this string of carbons? In omega-3, it's 3 carbons in from the methyl group. In omega-6, it's 6 carbons in. These two fats are dietarily essential fatty acids for horses, for humans, meaning that they can't synthesize them on their own. Further, these polyunsaturated fatty acids can be divided into different chain lengths.
The ones we typically see in vegetable oils are 18 carbons long, and in polyunsaturated fat terms, those are considered short chain. We have omega-3 and omega-6 short chain fats. The omega-3s are ALA and SDA. The omega-6 is LA and GLA. These fats can be elongated and more double bonds can be added. When they're elongated and they're at least 20 carbons long, we consider them long chain polyunsaturated fats. On the omega-3 side, you have EPA and DHA as the main ones. On the omega-6 side, you have DGLA and AA, arachidonic acid. In nature, when horses are out grazing pastures, they have a lot more omega-3 than omega-6. The predominant polyunsaturated fats in pasture are short chain, and there's over 3 times as much omega-3 as omega-6. We've measured it in pasture in Kentucky and in Florida, and both of them have about the same ratio. So horses normally eat more ALA than LA. When we start adding fat to diets, though, that isn't the case. The 2 most common vegetable oils that we add to horse feeds are soybean oil and corn oil. Soybean oil, about 51% of the total fatty acids are LA. LA, that's a short chain omega-6 fat. Corn oil, it's even higher, 57%. And you can see the amount of omega-3 is fairly small, 7% in soy, only 1% in corn. So the ratios of omega-6 to omega-3 are much, much higher in these oils than they are in pasture. There's flaxseed oil that is a good source of ALA. About 56% of the total fat there is in this 18 carbon. It's a short chain fat, but it's an omega-3. But there's another source of omega-3 fats, and that is fish oil. Fish oil, the fat actually comes from longer chain fatty acids, EPA plus DHA. We've worked with fish oil for a long time, and we have a product that we've had for a long time called EO3. It's a source of EPA and DHA. So when we look at fats, typically we feed from plant sources, either LA or ALA. So those are the 18 carbons. There are a series of enzymes that take those and desaturate them, meaning you add another double bond, or elongate them, you add more carbons. And you go from the short chain to these longer chain fats. Why is that important? The reason it's important is it's those long chain fats have some really important roles to play in metabolism in a lot of different areas. These longer chain fats are incorporated into cell membranes, every cell in the body, and they are used to produce a lot of lipid mediators that control inflammation, insulin sensitivity, bone formation, all sorts of things. So supplying these longer chain fats becomes an important function of these shorter chain fats. The problem we have is when we feed excess LA in the diet. That's LA is linoleic acid. That's the 18 carbon omega-6 fat that we have in vegetable oils. When that happens, this pathway shares the same enzymes with the omega-3 pathway, and ALA, the 18 carbon omega-3, is no longer elongated. And that's a problem because the longer chain fats that are made from ALA, EPA, and DHA are anti-inflammatory, and they resolve inflammation as well. The fats from LA in and of itself is inflammatory. Even this in its 18 carbon form, it also, when you have a lot of it, produces a lot of arachidonic acid, a long chain omega-6 fat that plays a role in inflammation. There's actually another long chain fat on the omega-6 side called DGLA. We rarely talk about it, but if you can produce DGLA, it is actually anti-inflammatory. We've discovered that there is an oil that supplies large amounts of GLA that can produce DGLA and can have some beneficial effects. So at the Performance Center that you saw in the earlier video, we did a big study where we wanted to see what was the effect of these different types of polyunsaturated fatty acids on performance in strenuously exercised horses. So we took 13 of our thoroughbreds that are in training at the research center that you already saw. We did not 3 90-day periods. We did a period that was pre-supplementation when the horses only got a hay and grain diet. They didn't get any supplemental polyunsaturated fatty acids other than what was already in the grain mix and the hay. We then looked at what was the effect of supplementation of fats, either from the short chain polyunsaturated fats or the long chain, and we did it in a switchback design. So this was the supplemental omega-3 intake that we had. On the right-hand side, I have a treatment that I'm calling SC-PUFA, that's short-chain polyunsaturated fats. We fed about 10 grams of that, of ALA, that's the 18-carbon fat, omega-3. We got that from flax oil. On the long-chain polyunsaturated fat treatment, we fed EPA and DHA. Those came from fish oil. When we looked at how well the horses could then incorporate those long chain fats into red blood cells, we saw that when we fed EPA and DHA, we got a stair-step increase in the concentration of EPA in the red blood cell. Red blood cells, a very good cell membrane to measure because it's easy to get to and it's reflective of the concentration of other membranes in the body. So we use red blood cells as the blood cell or the cell membrane that we're measuring. So we got a stair-step increase. Look at when we fed ALA from flax oil, 0, 1, 2, 3 months of supplementation. ALA did not produce any EPA. Same thing happened with DHA. We got no change from the amount of DHA when we fed ALA. We were not elongating those fats. When we fed it directly, we did increase it. On the omega-6 side, we fed supplemental. The short chain was LA, that's linoleic acid, the 18-carbon omega-6. That came from corn oil in this experiment. We substituted that for 5.3 grams a day of GLA that we brought from a proprietary source. What we found there was when you feed GLA to a horse, they can produce DGLA, and you see an increase in that. DGLA, again, has an anti-inflammatory and inflammatory resolving activity. If you look at the ratios of these fats, inflammatory, which is the arachidonic acid, to the combination of all the others, you see that when we're not supplemented, we have more AA than the sum of all the others. When we just use flax and corn oil, we didn't change that ratio any. But when we were able to add EPA, DHA, and a precursor of DGLA, we got that ratio 1-to-1. We did standardized exercise tests with these horses to see how it affected performance. And we measured a whole bunch of different things in these horses relative to exercise. And the long chain polyunsaturated supplementation resulted in a whole laundry list of good things happening. When they were on the long chain polyunsaturated fats, we reduced their heart rate during the most intense form of exercise. we actually enhanced mitochondrial biogenesis, the number of mitochondria in the cell. We reduced the incidence of bleeding, red blood cells in the lungs. We reduced the amount of eosinophils, a white blood cell that's related to airway inflammation. And we increased the amount of some anti-inflammatory cytokines and decreased the amount of inflammatory cytokines. And finally, we reduced the incidence of gastric ulcers. So all of these things are very good. The gastric ulcer paper is in press and should come out here this fall. So adding long chain polyunsaturated fats can have a beneficial effect, particularly if you're feeding them to a horse that has an excess of linoleic acid in its diet and not enough ALA. You can have a beneficial effect on inflammation in both the joint and airways, reduce the incidence of EIPH or bleeding, reduce the incidence of gastric ulcers. So this was about a 2-year project that we've done, and it's resulted in a new product that KER is planning to launch in the near future. So if we move on from fat and we look at, let's go back to dietary fiber. The reason that we weren't using dietary fiber is because it didn't have enough calories. Well, there are sources of dietary fiber that do have enough calories, and beet pulp kind of leads the pack there. We call beet pulp a super fiber. The reason we call it a super fiber is it's extremely digestible. We throw into this category also soy hulls. They have digestibilities that are a lot higher than traditional forages like from pasture or hay. And beet pulp can have almost as much digestible energy as oats. So we use fermentable fibers as a tool to supply energy in horses where we don't want to have too much carbohydrate or too much fat. And then finally, protein. Protein can be added as a source of energy, but that's not really what we want to do. Protein should be used for building blocks, and also protein has another interesting function. If we look at muscle development, muscle mass is really how much muscle mass you have is the sum of how much is synthesized minus how much of the muscle is broken down. So if we can stimulate the muscle to synthesize protein, reduce muscle breakdown, and give it the building blocks, we can build muscle. And there's been some interesting studies showing that there are things that signal the muscle to build muscle. One of them is insulin. So having higher carbohydrate diets and elevated insulin signals the muscle that it's time to grow. But also there's some specific amino acids, branch chain amino acids, leucine in particular, that also stimulates the muscle, tells it needs to synthesize muscle rather than break it down. So combining this with the appropriate amino acids for muscle growth is what we're trying to do. So bottom line is, what do we feed different types of performance horses? What form of energy should we supply? The answer is it depends on what kind of performance horse and what the diet is going to have in terms of these different combinations. Here's that slide again that I showed. Muscle glycogen is a function of speed. If you have endurance horses that are down in this speed, the amount of muscle glycogen they're burning is relatively low. You're going to have less of a dependency on NSC. You're going to look more at fat. If you go to eventing, a sport horse, you see that there's a mixture of substrates that are being used. Glycogen utilization becomes more necessary, but they can still use fat. So these horses are looking at a mixed bag where you want to have these energy substrates from both fat and carbohydrate. But when you get into racing, racehorses need to have a lot of carbohydrate in their diet. They need to have some fat as well. They need to have some fermentable fiber, but you need to concentrate on making sure that they have adequate NSC and that it's mixed correctly with fat and fermentable fiber. So higher NSC diets for strenuous exercise. Again, we've got hindgut acidosis that we have to worry about. We can attenuate that acidosis by processing the grain, feeding smaller meal sizes, using buffers, encapsulated buffers like EquiSure. And there's a whole big field right now going with different types of biotics, pre, pro, post, all sorts of different things that can be added to feeds that affect the hindgut environment that may have some efficacy as well. There's a lot of research going on in that area right now, so stay tuned for that. Higher fat diets are appropriate for lower intensity exercise. They work fine for most sport horses and endurance horses. The balance of omega-6 and omega-3 becomes a little bit of an issue. And since vegetable short chain polyunsaturated fats like ALA from flax oil don't really efficiently elongate to long chain sources, it's a good thing to supplement those. If you think you're in a situation where you've got that ratio way out of whack, being able to provide EPA, DHA, and DGLA can have some important health implications for performance horses. Then finally, highly fermentable fiber sources, the super fibers so-called, should be used for all performance horse feeds. And their use, the amount's going to depend on what you're trying to do with the horse, what balance of energy sources you need. And quality proteins important not as a source of energy, but to stimulate muscle synthesis with branch chain amino acids and provide substrate for muscle synthesis like lysine, methionine, and threonine, which are the first three limiting amino acids for horses. So back to how do we formulate different types of performance horse feeds? These are pie charts that come from a new software program we developed called the KER Formulator. This is probably the most sophisticated equine feed formulation program in the world. It allows us to formulate using energy partitioning. So when we're making individual rations, we're looking very specifically at where we want those calories to come from. It's one of the most important things we do when we formulate horse feeds. This formulator, we've just launched it. If you're interested in that, give me a call and I'd be happy to explain some more about how this sort of formulation works. So I'm going to stop right there. Hopefully I've covered a lot of territory. There should be a few questions.
All right. Thank you, Dr. Pagan. Before we get started answering questions, though, we'd like to share a brief video. Then we'll be right back to answer the questions submitted during today's presentation.
Organic trace minerals come in many types and formulations, leading to confusion about chemistry, terminology, and methodologies. With Balchem's Keysure line of chelated minerals, we provide superior performance and exceptional value by keeping it simple. Binding minerals to the highest quality plant protein-derived amino acids and peptides in our world-class production facilities, using a true chelation process pioneered by Balchem and trusted in both the human and animal arenas for nearly 60 years. The Keysure line delivers proven and consistent bioavailability to maximize performance, and a no-frills pricing approach for greater profitability. Visit balchemanh.com to see how Keysure chelated minerals are your link to superior performance and exceptional value.
All right. As a reminder, you can still submit questions through the Q&A tab at the top of your screen. Dr. Pagan, our first question comes in from Rob. Rob is in the Netherlands, and he wants to know if AHI flower oil have a similar fatty acid profile as fish oil.
No.
Okay.
It doesn't. That oil is high in two short chain omega-3 fats, ALA, which I talked a lot about, and SDA. So it's a different profile. It is a vegetable source. Typically, if you're going to look at fats that have long chain polyunsaturated fats, they're going to come from marine sources. They may come from fish or they may come from algae, but that's typically where the long chain omega-3s are derived from.
All right, very well. Next question is from Isan, and he'd like you to elaborate on the exact differences between race and sport rations.
Okay, well, again, it's the energy balance that's most important. Typically, you're going to feed race rations at higher levels of intake too. A racehorse is going to eat about 6 or 7 kilos of feed. So the concentration of all the micronutrients that we add, we have to take into account that level of intake. But the big thing is where we're getting the carbohydrates or where we're getting the energy. We're focusing a lot more on non-structural carbohydrates with a balance of fat and fermentable fibers. Sport horse feeds, we go kind of in the opposite direction. One other thing that I didn't discuss here that high carbohydrate feeds can do is affect behavior. So in some sport horses, if you take some of the starch and sugar out, add fat and fiber, the horses tend to be a little less excitable. So a lot of times we will add that to sport horse feeds to make it where they don't get quite as spun up, but we still have enough of the different types of calories to do the job for muscle metabolism.
All right, very well. You got a nice shout out from Fernando. He appreciates the conference, so nice job there. Next question comes in from Juan. What feeding strategies should be implemented in order to avoid high body temperatures in endurance horses during competition?
That's an interesting question. One of the good things about feeding fat is that the overall energy load that is given, that's created from fat is lower. So adding fat as a substrate for energy generation can reduce the load. And so we're already adding fat as a substrate for endurance horses. So that is a good thing. Fiber has a tendency to increase overall heat, but I would say that it's well worth it. The extra heat load that might be produced from fiber is offset by its importance in GI health. So I think concentrating on having diets where you're using fat as your predominant energy substrate will help with the heat load, and not overdoing protein as well, which you don't want to have in an endurance horse.
All right, I've got a couple questions related to regular sodium bicarbonate versus the encapsulated.
Yep.
This one comes in from Benjamin, and he wants to know if it'd be useful to use just regular sodium bicarbonate orally in performance horses.
Okay, well, good question. You can use oral bicarbonate, but one of the problems is if you do that and you're feeding a racehorse, when oral sodium bicarbonate is fed, it is immediately broken down in the stomach, and carbon dioxide is produced, absorbed into the horse's bloodstream, and it increases TCO2, total carbon dioxide. Elevated TCO2 in racehorses, standardbreds, thoroughbreds, Arabians, is prohibited. And so if you feed raw bicarb to a racehorse, and if you do it intentionally, a lot of people do it, and it's called a milkshake, where you give large amounts of it. You're trying to elevate TCO2 in the blood. It's an alkalizing agent. It's illegal. So with EquiSure, we did a lot of studies looking to make sure that EquiSure did not cause that effect. We did not want an elevation in TCO2. Even having said that, we recommend that all of our products are withheld 24 hours before racing, which is the rules of racing for any kind of supplementation. But feeding raw bicarb to a racehorse is not a good idea unless you want to get a positive drug test.
All right, very well. Just another quick question on clarification. Could you define the difference between a racehorse and a sport horse?
Sure. Racehorses are used in racing. Thoroughbred racehorses typically go from 6 furlong races, 1,200 meters, up to a couple of miles. They go really fast. They will run at about 16, 17 meters a second. To put that in perspective, the fastest human sprinter runs at about 10 meters a second. That's as fast as you can go. Racehorses run really fast. Sport horses are used for things like show jumping, dressage, where there is less intense exercise and there's more attention paid to jumping, to dressage skills, that sort of thing. So the intensity of exercise is less than racehorses. Quarter horses are really the highest intensity, the fastest for a short period of time. Quarter horse racehorses, then thoroughbreds, then Arabian racehorses, then finally standard breds. All of them go really fast, though.
All right, very well. Good distinction. Danielle is asking, could the addition of amylase, carbohydrates, help digest excess grain in diets and avoid acidosis?
There's been some studies looking at exogenous enzymes to improve digestibility. They've been a little bit mixed in terms of their the efficacy. I mean, it's a good idea. Whether the enzymes actually survive, the feed processing that you do, that's still, I would say, a bit of a work in progress. I think feed processing and meal size are probably two of the things that we know work for sure. One of them's a feed milling technique and one of them's feeding management, but that's kind of where we go right now in terms of those trying to reduce acidosis.
All right, very well. Does omega-3 supplementation help with pain relief or inflammation in arthritic horses?
The long chain omega fats have an effect on response to inflammation. And response to inflammation and the pain from inflammation are related to that. If you look in the human literature, when you're looking at long chain polyunsaturated fats, both on the omega-6 and omega-3 side, pain relief and chronic type of orthopedic problems respond to that type of supplementation.
There was a question related to some of the rumen inert fats that's been developed for the dairy industry, and are they appropriate for feeding to equine?
Yeah, very early on, when those came out, we did research with those, and we found the ones that were calcium salts were not terribly palatable for horses. But the other thing we found is they were pretty indigestible. The digestibility of vegetable oils can be up over 90%. They typically are over 90%. When we use some of those rumen protected fats, we were getting digestibilities of 50%. So we had a problem with both palatability and digestibility and really didn't go very far with that technology for horses.
All right, thank you for that. Staying with fats, should we increase DHA and EPA intake in young weaned foals for better trainability, similar to working canines?
Well, that's a good question. I mean, if you look again in the literature for neural development, there's certainly a role that DHA plays in brain development and nerve development. And so you'll notice a lot of DHA fortified baby formulas and whatnot. And the idea is it's a really important nutrient for that type of development. So there's no data in horses to say that that's necessarily true. But if you look at the data in humans and other species, there's a possibility that might actually be something to have a look at.
Okay. Another fat question. Is there any upper limits to omega-3 fatty acids to be fed at, and will it impact palatability?
Yeah. So the downside of using marine-derived fats is fish oil in general is not all that palatable. We've taken a lot of time using different types of distillation techniques and purification to try to make those fats more palatable with flavors. So we've greatly increased the palatability of those fats. Now, having said that, they're still not as palatable as vegetable oils, and I don't think they ever will be. The thing that's amazing about these oils, though, is that study that I showed you that had pretty incredible physiologic results. We were only feeding about 5 grams of each of those different types of long chain fats per day. 5 grams, that's a very small amount. So our recommended level of intake for these oils is about 1 to 2 ounces a day. People confuse oils that you need to feed lots of it. You do if you're trying to use it as a source of energy. If you're feeding long chain polyunsaturated fats, you don't feed very much of it. So that study, again, that was 2 ounces of oil that was supplying those levels of long chain fats. And I would not advise feeding any more than that. We got very good responses in terms of incorporation in cell membranes and the physiologic responses at those low intakes.
Joe, we just passed the top of the hour. Can you hang on for a few moments? We got a few more questions.
Sure.
All right. Next question is, what antioxidants are most important for performance horses?
Okay, I didn't have enough time to talk about that today, but that's another really interesting area that we've been studying recently. Obviously, vitamin E is sort of the leader there. Trying to improve the bioavailability of vitamin E is much like the encapsulation issue. Can you deliver it to the right cells? We've also been studying some other interesting antioxidants. One of them is coenzyme Q, coenzyme Q10. Again, bioavailability was a little bit of a concern. We were able to figure out a water dispersible form of coenzyme Q that horses can utilize. Again, doing a lot of work with Dr. Valberg's lab at Michigan State and Dr. White's lab at Texas A&M. We've shown that those antioxidants can get into horse muscle, are powerful antioxidants, and play a role in energy generation as well. Finally, there's not an antioxidant, but a substrate of an antioxidant called acetylcysteine that's a substrate for glutathione production, which we're using for some horses that have some specific muscle myopathies that can't produce glutathione on their own. And that's showing a lot of exciting promise as well.
All right, thank you. I want to thank Hassan for the very kind words that he's written here as a comment, not a question. Next question is from Daniela again. Do you have experience with the use of seaweed oil instead of fish oil?
No, not with seaweed oil. I'm not familiar with seaweed oil. I mean, I'm familiar with seaweed, and we have used seaweed, and we've used seaweed-derived calcium, but I have not used seaweed oil, so I'm afraid I can't really even comment on that.
All right, very well. So why don't we take one more question? What do you see as the most important research topics and technologies in equine nutrition research in the future?
Right. Well, that's a good question. I think these new technologies, the proteomics, the ability to look at gene expression is completely opening a new realm in us understanding how nutrition actually affects physiologic function. So as those techniques come onto the scene and improvements in understanding the microbiome and that sort of thing, we're going to see using these new genetic techniques to understand the role of nutrition. That's a big one. So that's real space age, but I'm going to put in the other one that is sort of retro. In today's climate, where raw material prices have gone through the roof and feed manufacturers are really stressed about what can we add to horse feeds, one of the big new areas of equine research is the use of other types of feed ingredients to provide the nutrients we know that horses need. That stuff that was done a long time ago, I would call that almost more classic nutrition. but because of the world economy, that's going to be at the forefront. It's one of our main goals and priorities, is to understand how we how we can produce feeds that are nutritionally as good but more cost effective. So that, stay tuned for that research.
All right, very well. Thank you very much for a very enlightening presentation today, Dr. Pagan. I really enjoyed it. Also want to thank everyone for attending today's webinar. If you have additional questions, please submit them to anh.marketing@balchem.com. The Real Science Lecture Series of webinars will continue on September 6th when we're joined by Dr. Mike Van Amberg from Cornell University. Mike will review the key updates to the CNCPS version 7 that practicing nutritionists need to know. And on October 2nd, we'll hear from Dr. Kevin Harvatine from Penn State University. He will share how to best manage both fat and protein in a tiered milk pricing system. Also plan to join us on November 15th when we welcome back Dr. Temple Grandin to share insights into animal behavior and autism. Visit balchem.com/real science for more details and to register for all future webinars. Balchem's podcast series continues to offer a deeper dive into our webinar topics. Log on to your favorite podcast platform or visit balchem.com/podcast. We'll be recording a podcast with Dr. Pagan soon, so be sure to subscribe to the Real Science Exchange so you don't miss it. And if you send us a screenshot along with your address, shirt size, we'll send you a really cool Real Science Exchange t-shirt. And with that, on behalf of Balchem and Dr. Pagan, thank you for joining us today.